All right, guys, we're starting chapter 4 now. Do you believe it? Already into chapter 4, which is all about equations of linear functions. So section 1 is called graphing equations in what's called slope-intercept form. So previously you found rates of change and slopes, and now we're going to write and graph linear equations in slope-intercept form and model real-world data with equations in slope-intercept form. All right, so new vocabulary, slope-intercept form. So let's get right into it. An equation of the form y equals mx plus b, where m stands for the slope and b stands for the y-intercept, is in slope-intercept form. And the name actually says it all. In slope-intercept form, you can look right at the equation if it is in slope-intercept form and pick off the slope and the y-intercept. That's why it's called slope-intercept form. So the variables m and b are called the parameters of the equation. Don't let that scare you. That's just a fancy way of saying that m and b stand for the slope and the y-intercept. And what happens is if you change the slope or the y-intercept, it changes the way the graph looks. So in words, the slope-intercept form of a linear equation is y equals mx plus b, where m is the slope and b is the y-intercept. Yeah. So for example, if you have y equals mx plus b and you replace 2 with m and 6 for b, you would have y equals 2x plus 6, where 2 is the slope and 6 is the y-intercept. And we're going to talk about how to just look at that equation and graph it right from there. Okay, so let's write an equation in slope-intercept form for the line with a slope of 3/4 and a y-intercept of -2, then graph the equation. So let's start off with slope-intercept form in general, y equals mx plus b. Okay, they told you what the slope was and they told you what the y-intercept is, so we replace m with what it is, 3/4, and b with what it is, -2, so you should have y equals 3/4 x plus -2. And if you just simplify that, when you plus a negative, it's the same thing as subtracting. Okay? And then you want to graph the equation. So plot the y-intercept. Remember, y-intercepts are always 0, the number. Okay, and they should cross the y-axis because it's the y-intercept. Well, since they already told you what it is, it's -2, you know the point is 0, -2. Then once you do that, you use the slope as directions from the y-intercept to the next point. So remember, slope is rise over run. So since it's already a fraction, 3/4, that means you're going to start at the y-intercept and rise 3 points and then run forward 4 points and then plot another point. And then once you get those 2 points, you can draw the line. So here's what we have here. The y-intercept is -2, so we plotted a point here. And then we took the slope as directions to the next point. We went from here and we went up 3, 1, 2, 3, and forward 4, 1, 2, 3, 4, plotted another point, and then drew a straight line through those 2 points. That's simple. All right, here's one for you to try. Write an equation of a line in slope-intercept form with the given slope and y-intercept, then graph the equation. Go ahead and pause the video and try it out. All right, we're back. What you get? Your equation should be y equals -3x minus 8. Okay, the slope is -3 and the y-intercept is -8. Oops. Okay, so in this one it's a little bit different because the slope is not a fraction, but that's fine. Okay, the slope's the y-intercept's -8, so you go 1, 2, 3, 4, 5. So you would go down 8. And put your point. That's the y-intercept. That's 0, -8. Then your slope is -3. And remember, you think of slope as rise over run, but it's -3 over nothing there. But remember, any integer you can make into a fraction by putting it over 1. So you would rise -3, which really means go down 3 and then forward 1. So you start at the point that the y-intercept, you go down 3 points and over 1. And that would be your second point, and you can draw a line through those 2 points. Now, you can do that again from that second point, go down 3 over 1 again, and it would give you a third point, go down 3 over 1 again, that would give you a fourth point, and so forth and so on. But you really only need 2 points to draw a line. All right? So write an equation. When an equation is not written in slope-intercept form, it may be easier to rewrite it before graphing. So if I want to graph 3x plus 2y equals 6, I want to first rewrite the equation in slope-intercept form. So how we do that is you take the original equation and just solve it for y. In other words, get y by itself. So first thing you'd have to get rid of is the 3x. So you'd have 2y equals, now a lot of people would write 6 minus 3x, but you want to put it in slope-intercept form, so the x should go first. So it should be negative 3x, and the 6 itself was positive, so you would write it as plus 6. Then divide everything by 2. So you'd have y equals negative 3 halves x plus 3. Now, I know technically that would be negative 3x divided by 2, but negative 3x divided by 2 is the same thing as negative 3 halves x plus 3. Now, from that, you could pick off the slope and the y-intercept. The slope is the number in front of x, negative 3 halves, and the y-intercept is the number by itself, the b, or plus 3. So you would go up 3, put a point for the y-intercept, and then take the directions from the slope to get your next point. Go down 1, 2, 3, run 2. Okay, then you could get a third point. Go down 1, 2, 3, run 2. And if you're doing it right, your points should show up in a straight line. Like that. Okay? Pretty cool stuff, huh? All right, here's one for you to try. Graph 3x minus 4y equals 12. Go ahead and pause the video. All right, we're back. What you get? Well, you got to take the original equation, subtract 3x from both sides, and you get negative 4y. Don't forget that it's still minus 4y equals negative 3x plus 12. Then divide everything by negative 4. Those cancel. You get y equals, now look at this. You have negative 3 divided by negative 4, which is going to be 3/4. Don't convert it to a decimal. If you got 0.75, that's fine, but how do you graph 0.75 if you're thinking of it as directions to your next point? Leave it as a fraction. Then 12 divided by negative 4 is negative 3. You plot negative 3 for the y-intercept, so just go down 3. And then the slope is 3/4, so you would rise 3 and run 4. Okay, slap a line on there. And you have your line. All right, pretty cool, huh? All right, so except for the graph of y equals 0, which lies on the x-axis, horizontal lines have a slope of 0. They are graphs of what's called constant functions because there's no x in the equation, which can be written in slope-intercept form as y equals 0x plus b. But since there's no slope, the slope is 0. 0 times x is 0, so you really just have y equals b. And b can be any number. So constant functions do not cross the x-axis except when it's y equals 0, then it is the x-axis. If their domain is all real numbers and their range is just that number. Okay, so if I want to graph y equals negative 3, I plot negative 3 and then draw a horizontal line with a y-coordinate of negative 3. That's it, right there. That's a constant function. All right, so you go ahead and pause the video and try these two. Okay, we're back. What you get? So the first one, y equals 5, you would just go up 5, put a point, and a horizontal line. The second one is a little bit tricky. Is it in slope-intercept form? Technically, it's not because it's not solved for y. So just solve it for y. Divide both sides by 2, and you would have y equals 1/2. So be careful. That's y equals 1/2. It's not 1/2 x. So it's not like you go up 1 over 2, up 1 over 2, or anything like that. If this is 1, this is the constant function y equals half, which means it's a horizontal line that goes through 1/2 on the y-axis, which would be halfway between 0 and 1. and then you just have a horizontal line there. Okay? So just be careful about that. All right, vertical lines have no slope, so equations of vertical lines cannot be written in slope-intercept form. Vertical lines have the form x equals b, and they'd be vertical lines going through whatever b is on the x-axis, and it would go up and down. But notice you can't solve that equation for y because there is no y. So technically, vertical lines can't be written in slope-intercept form, and that's why, because there is no y in the equation. All right, there are times when you will need to write an equation when given a graph. To do this, first, check out what the y-intercept is, and then use rise and run to find another point on the graph. Then write the equation in slope-intercept form. So let's do this one. Here we are right here. Oops. Now, if you look at this equation, even though there's no tick marks, if the graph doesn't have tick marks on it, like it doesn't label what each tick mark is, I should say, you assume they all go by ones. So here, I know that the y-intercept is 1 because it just crosses the y-axis at 1. Then what you do is find another point where the graph crosses the crosshairs. So you could either use this point right here because it crosses right at a corner, or this point because it crosses right at a corner. Okay, I usually try to pick a point to the right of that point just because it's a little bit easier. So you do your rise first, and actually you have to go down 1. So I know my slope's going to be -1, and then I have to run 3. So it'd be like that. So -1/3. So my equation is y equals mx plus b, so -1/3 x plus 1. If you went backwards, if you started here and went to this point, you would have to go up 1, back 3. So it'd be 1 over -3, which really is the same as -1/3. You know, -1 over 3, 1 over -3, and -1/3 are all the same numbers. So just be aware of that. Okay. This one, go ahead and pause the video and try that one. Okay, we're back. What'd you get? Did you get y equals 1/4 x minus 1? Yeah, the y-intercept's -1, and then you have to rise 1 and run 4 to get to the next point. Okay, or you have to go down 1 and back 4, which would be -1 over -4, which is still 1/4. All right, well, that's it for this first video. We'll finish out this section with the second part in just a minute. See you there.